I'll start with a new scene. Use the head bus as an example. I'll zoom in. Have wireframe turned on. You can see different densities between the separate objects. I want to show one distinct difference that's very helpful to know whenever you are merging objects together, because surface mode, when I shift drag this little move icon on the ear layer to the bust layer and release, you'll notice it preserves the separate densities. This may be what you want in some cases. I'll do the same thing for the ears. Remember, when you want to merge objects together, you can do it in surface mode, but as you increase the level of complexity, then you might have to wait longer for the calculation, and that calculation after you wait might not actually work. It might give you an error message, so that means you would probably need to switch to voxel mode in order to merge parts together. But when the objects are rather simple, like this, or when you're using primitives, then merging objects together is fairly simple and easy to do in surface mode. Let me go back to voxel mode. And this one is all voxels rather than surface mode, and you'll see when I do the same thing, it's going to adopt the resolution of the parent layer. You see that? Big difference. Same thing with the ears. So that's something you really need to keep in mind when you merge parts together. If you've got a lot of detail on the object that you're merging into the parent layer, then you want to keep in mind whether or not that parent layer has sufficient resolution. And while I'm at it, I just want to quickly add a little bit more resolution, and I want to show when you brush, you can see that 3D Coat is doing this all on the fly. It's turning on and turning off voxels on the grid, and it's remeshing as you brush. When you get into extremely dense models, when you're trying to work on wrinkles and pores and things of that sort, it's very important to know that voxels are not as efficient when you are working on extreme resolution levels. Because, for one thing, that dual calculation starts to become more pronounced. It's not that noticeable on an object like this. It's very fast and very robust. And you also happen to have the ability to use CUDA if you have an NVIDIA card. That helps to some degree, but again, when you're really cranking up the resolution and you need to work on that microsurface level detail, you have two options that may be much better, and that is surface mode, and also you can wait till you're in a texture painting stage and use image-based sculpting for that. It's much more efficient. You can blend the layers together. You can mask layers. It's just a great overall platform to utilize when you're trying to do surface level detail. If you can, try both on different projects or on different models and see which ones you prefer. I'm going to undo a few times here, and I'm just going to switch to surface mode. You can see it's near instantaneous. Now let's look at dynamic tessellation. One of the primary means of applying adaptive subdivision is using live clay. It will allow you to sculpt and dynamically subdivide as you are sculpting. If you want to simply subdivide locally, you can right-click and drag till your profile is flat. That means your depth level is at 0. Therefore, live clay will not sculpt. It's only going to subdivide. If you have a large brush and start sculpting, you'll see a difference in density. The smaller the brush, the higher the density. You can offset that by increasing the detail level. So for example, if you're trying to dynamically subdivide an entire portion, let's say the face region, let me hide the eyes. Yeah, let's increase that to, let's say, 8. I can use a large brush to give the entire region quite a bit more resolution. And then you can proceed to sculpt however you want. You don't have to subdivide while you're sculpting. You can use all the other brushes. Okay, so let me undo. There's another alternative to doing what we just performed, and that is Subdivide. This uses a slightly different algorithm for subdivision. It's called loop subdivision, and it allows you to paint select an area first before it does any subdividing. Let me undo, and I'll turn symmetry on. Yeah, there we go. You can also use shapes from the E panel. To quickly make your selection. Let's hold the control key and I can deselect certain parts. And now we have options for exactly how we want to apply this. Do we want to apply it to everything outside the mask portion, or to the mask portion, or to the entire object? We'll choose to the frozen area and then hit apply. You can see it's much more dense. Okay, so that'll be enough. To clear this, you can click clear selection, or just as you would clear a selection in Photoshop, Control D. Now we can choose something like Rapid 2. I'll turn wireframe off. Now going back to calculations again, surface mode for brushing is actually faster and it's more efficient because it's not having to perform multiple calculations while you brush. It's just one. It only has to displace the vertices and that's it. So it's very robust, very brisk. And you also happen to have a default set of presets. The ones with a AM prefix are Artman's brushes, so you can try these and test these out. Let's try AM polish. Trim, more like trim dynamic in ZBrush. So if you're coming from ZBrush, you probably want to experiment with many of these, and you can tweak them. Once you've tweaked the settings and you have it the way you want, you can update it by right-clicking and choose Update Presets. Okay, so one last example here is using the Cutoff Tool. When you are doing hard surface modeling in 3D Coat, if you use the Cutoff Tool in surface mode, it has a distinct advantage of applying dynamic tessellation along the edges, so you get extremely crisp edges. Razor sharp edges. Let me undo and I'll use something like the polygonal lasso. You can even go in at a depth limit. So this is definitely one option you want to utilize whenever you are hard surface sculpting. Voxels are great for booleans and modeling in general, but you have to exaggerate the resolution in order to maintain sharp edges, so keep that in mind. And that's going to conclude our look at the differences between voxel modeling and sculpting and surface mode modeling and sculpting. Thank you for watching. We'll see you in the next video.